so this is geometry, target B and target E. Dr. Turner's class, we're going to be looking at the distance formula, how to find the distance between 2 points. We'll also be looking at the midpoint, which is defined in the middle. Using that midpoint formula to find the middle point and also the 2 endpoints of the line. So to start off, let's look at the distance formula. We have our graph. We have 2 points. And I'll attempt to make it as, I'm not really going to name them. They're just going to be generic. X1, Y1, and X2, Y2. So the way it works, the way the distance formula works, let me write the formula for you. We're at the sign that we promised. X2 minus X1 plus Y2 minus Y1. So things to take note of, X2 and X1, we're just subtracting our X coordinates. Y2 and Y1, we're subtracting our Y coordinates. It doesn't really matter which one you subtract first, what you call Y1, Y2, because what we're going to do is to square whatever we get. Okay? So let's do a quick example. Okay, so this is our first example. We have our first point, 5, 1, and our other point, -3, 3. What we're trying to do is to find the distance between them. So we're going to try to find the distance between these two. So let's represent that with a quick blue line. So the distance between these 2 points, right here. Okay? We're trying to find the length of that blue line. So essentially what the distance formula does is it breaks down the distance into linear, vertical and horizontal distance. So if we talk about our vertical distance, our up and down, that's our X and Y. We're looking at the height difference between our point 5, 1 and -3. And we're looking at the horizontal distance between, again, this point 5, 1 and -3, -3. Okay? So what you see is it looks like a triangle, basically. And so again, what we're trying to do is look at this horizontal distance, which is our Y components, our Y coordinates, and this distance here, which is our X coordinates. Okay, so again, the difference between X and Y. So let's just go ahead and pull them out. Our X coordinates, just to make this a little neater. Our X coordinates are 5 and -3. So our distance formula, square root of X2 minus X1 squared plus Y2 minus Y1 squared. Our X coordinates are 5 and 1. Our Y coordinates are 1 and -3. So we're going to add our Y coordinates, 1 and -3. What's important to see What I did right here, I subtracted a negative. Make sure you don't forget that when you do your problem and when your component is negative. Also look at the order. These first two came from this first coordinate. These two came from this second coordinate. Alright, so now we just go through and we do our math. Five minus 1 is 4, so we have 4 squared. 1 minus negative 3 is 4, so I'll also have 4 squared. So that gives me 16 plus 16, which is the square root of 32. So like we talked about in our radical review, we don't have a perfect square radical, so what we're going to do is have to break that square root of 32 down. So we can break that down, and I'm just going to rewrite it in a more centered way so I can work with it better. For me, the first thing that comes to mind is 8 times 4. Square root of 8 times square root of 4. I notice automatically that that square root of 4 is a perfect square, so that can just become 2. The square root of 8 can break down to, again, square root of 4 times square root of 2. Again, here's my perfect square, so I bring my 2 down for bookkeeping purposes. And like we talked about, when they're out from underneath the radical sign, they just go out in front of our radical. So we'll have out front 2, another 2, and then our radical 2. So it's just 4 square root of 2. So that distance between these 2 points, distance between 5, 1 and negative 3, comma 3, negative 3, is 4 radical 2. So again, remember this radical is a number. It represents numerical quantity. So even though we haven't seen things expressed in radical form before in terms of distance, the same rules apply. We can't come up with a negative number. We can't have negative distances. Also, we can't have negative numbers under our radical sign. So if we square 2 things, go back up. If we end up squaring 2 things, and we come up with a negative number here, we've done something wrong. Okay, after we square something, we should not have a negative number. Negative times a negative is a positive. Let's do some more examples. So let's look at an example where they don't really give us a graph. Let's look at an example where they actually just give us the coordinates. So let's say they give us a coordinate. C as a coordinate of negative 10 and 2. B as a coordinate of negative 7 and 6. So we're going to again apply our distance formula to our x coordinates and our y coordinates and find the distance between these 2 points. So our distance formula is now, I suggest, as you're doing this, always write the formula just to remind yourself of what goes good practice in general so you don't lose place of what you're doing. So our first x coordinates, remember they're going to order. So negative 10 minus negative 7, square that, plus 2 minus 6 squared. So 10 minus negative 7 is going to give me a negative 3. Don't forget my square sign. And 2 minus 6 is going to give me a negative 4. And remember I said we can't have negative numbers underneath our radical sign? That's why it's important to always make sure we don't forget this square. Because we're going to be multiplying negatives by themselves, which means these negative signs end up going away. So negative 3 squared is a positive 9. Negative 4 squared is 16. Positive 16. We add those two together. 9 plus 16. And we get 25. So luckily for us, the square root of 25 is a perfect square. So our distance is just equal to 5. One thing I want you to take note of again is the organization of it. Like we talked about in class, I have my formula, and step by step, I go down and show my number at the end. That way we can find where we made mistakes. We can also see our progression of logic and see why it makes sense. Remember we said in geometry, this is not so much the study of shapes, it is the study of how to create and defend a point or an argument and state your claim and have a defense for it. So this way right here, we have justified our reasoning as to why the distance between these 2 points is 5, and laid out each point clearly. Let's take a look at another example. Okay, so we have 3 points, x and x, which is going to be coordinates negative 2, comma negative 1. I'm going to have point y, which is coordinates 2, comma 5, and then coordinate z, coordinate 4, comma 3. So what we're going to do is we're actually going to find the perimeter of the triangle that is created by these 3 points using the distance formula. All right? This is the application that will show up on your SOL, so make sure you pay attention to it, pay close attention to it. Let's take a look. Let's do 3 different colors. So we'll have a point from here to here. We'll have a point from here to here. And our third side from here to here. So we have 3 sides of my triangle. What I'll do is I'll try to color, I will color code each distance formula, so that way we know which side we're talking about. Let's do the green side first. Again, write our formula. The square root. My x coordinate is 4 minus negative 2. That's squared. Plus my y coordinate 3 minus negative 1, and that's squared. So 4 minus negative 2 is going to give me 6 squared. And 3 minus 1, sorry, 3 minus negative 1 is going to give me 4 squared. Which is going to give me 36 plus 16, which then equals, give me the square root of 52. And I will go through and break down. We're going to simplify that radical. 26 because, again, even though I am a mathematician, I just don't keep the times tables that high. Just in my brain, I saw it was even, so I used 2. 2 and 26 again. Things I don't know, but I know that 26 is an even number, so I'm going to bring this square root down to bookkeeping. And that gives me the square root of 13. Now I know I can't go any further because I know that 13 is a prime number. It's only factors of 1 and 13, so I can't break this down any further. But like we talked about, I have 2 the same number under a square root, so that's going to come out just as a normal 2. And so my answer is going to be 2 square root of 13. Okay, so that's my first one. Let's take a look at the red line, y and z. And take note of the notation. I'm going to use point y and z, the line segment yz. You may see it expressed this way on the test. So the distance of yz is going to equal, again, my square root formula. X2 minus x1 squared plus y2 minus y1 squared. So my x coordinates are 2 and 4. So my y coordinates are 5 and 3. So 2 minus 4 is negative 2. Negative 2 squared plus 5 minus 3 is 2. That's 2 squared. So this gives me square root of 4 plus the square root of 4. Now, square root of 8. You're going to come across the square root of 8 a number of times as you do these problems, just for whatever reason. My suggestion is to use just memorize it so you don't have to waste time simplifying and go through the steps to simplify it. Memorize it as 2 square root of 2. That's it. Every single time, 2 square root of 2. Let's do our last line, which is our blue. Our points are 2, negative 2, negative 1, and 2, 5. So we'll do the blue. And that's going to be line segment XY. So XY is going to be equal to my lovely distance formula again, because by now you are sick of writing it. But again, do it every time so that way you don't make the mistakes as you learn it, as you practice it. We'll fill our coordinates in. So the square root of negative 2 minus 2 squared plus negative 1 minus 5 squared. So what we're going to have is negative 2 minus 2 is negative 4. Square that. This gives us negative 6. We'll have 16 plus 36. Which will again give us 52. and from before, so we don't have to be repetitive in our process. We know that the simplification is 2 radical 13. So there we have it. We have our perimeter. Now it looks ugly. It looks like it's a form that we haven't seen before. Our perimeter P will equal 2, 0 to 2, plus 2 radical 13, plus 2 radical 13. And leave it this way. We can combine these two just to have the same radical. And we're left with that. Okay? So again, it looks different than what we're used to, but again, we're making a justification argument. These radicals are actual numbers, so it's an actual distance. And there we have it. So that's the distance formula.